We're going to walk through problem number 2 from vector applications warm-up, which is really vector applications using addition. So we're told that a plane needs to travel in the direction of 20 degrees west of north at a speed of 300 miles per hour. So I'm going to put the directions at north, south, west, east, so we have them as a reference. And now I'm going to draw in the vector that we're given. So this is actually the resultant vector. So the net effect of the velocity of the plane and the wind. So that's going to be 20 degrees west of north. So when we want to draw this, we're going to start at north. So we're going to start vertically, and then we're going to rotate 20 degrees to the west. So downwards from north. So this is going to be our resultant vector. So this is 20 degrees west of north. I'm going to label it R for resultant vector. And we're told that it has a length of 300 miles per hour. And then I'm also going to draw in the reference angle that we normally use, which is back to the horizontal. That'll be 70 degrees. Then what else were we told? We're told that there was a wind blowing in the direction of 50 degrees east of south at 40 miles per hour. So 40 miles per hour is the length. The direction is 50 degrees east of south. So that means we're going to start at south, and then we're going to rotate to the east 50 degrees. So I'm going to draw in a second vector. So it's going to be 50 degrees east of south. So something like this. And its length is 40. So this is 40 miles per hour. This angle is 50 degrees east of south, which means that our reference angle back to the horizontal is going to be 40 degrees. That's what we're used to. And now we need to find the velocity of the plane. So remember, the velocity of the wind, actually I'll label this vector that we just drew. I'll draw this, I'll label it vector W. So the vector which represents the wind plus the plane by itself has to equal the resultant vector. So what we're asked to find here is the velocity of the plane. So what we want to think about is taking the wind plus the plane, call that vector P, their sum. So if we go along both of these vectors, the wind plus the plane is going to be equal to the resultant vector that we're given. So I'll write that down here. So in the end, we're going to say that R is equal to wind, the vector wind, plus the plane. And we're given R and we're given the wind, but we need to find the plane vector. And we've already sketched the vector triangle, which it says to do at the end, but I like to do it at the beginning so we can see what we're talking about. Okay, so let's try to break this down. First thing I'd like to do is I'd like to find the vector R, the resultant vector, in component form. And we're given that information in polar form. So I'm just going to draw R separately so that we can work with that. So this was the vector R. It's 300 miles per hour, and our angle, the reference angle, is 70 degrees. And then we're going to find the horizontal and vertical components, and I'm going to make a note that the horizontal component has to be negative because we're in the second quadrant. And now I'm going to use right triangle trig, so I'm going to think about SOHCAHTOA. So I can say cosine of 70 degrees is going to be the x component over 300, which is the hypotenuse. And if you'd like, I can label this, the x component is the length of the adjacent side, the y is the opposite, and the 300 is the hypotenuse, if that helps you. Okay, so x is going to be 300 cosine 70 degrees. And 300 cosine 70 degrees, if you punch it into your calculator, will give you 102.6 miles per hour. But remember that this component must be negative in the second quadrant. So I'm going to remember to put my negative sign there. Likewise, I'm going to find the y component. So I'll use sine. Sine of 70 is y over the hypotenuse, which is 300. So y is 300 times sine of 70 degrees. And if you enter that into your calculator, you'll find out that the y component is 280.9 miles per hour. So to summarize, r in component form is negative 102.6, comma 281.9 miles per hour. Okay, so this is an intermediate step. The next thing that I like to do is figure out what W is in component form, because I know eventually I want to get back to finding P, because I want to subtract W from R to get the velocity that the plane, the course for the plane has to be set to. So for the next set of operations, let's find W in component form. So the wind vector in component form. So in order to do that, I'll make a little diagram of the W vector by itself. So W has a magnitude of 40 miles per hour, and my reference angle is 40 degrees. This is the W vector. I'll label it. And now we need to break this down into its X and Y components. I'll note that Y must be negative. In quadrant 4, X is going to be positive. So we'll use right triangle trig again, and we'll set up our relationships. Y is the opposite side, and X is the adjacent side relative to the reference angle of 40 degrees. And so we're going to say cosine of 40 degrees is going to be X over 40. So X is 40 cosine 40 degrees. And if we enter that in a calculator, we get X is 30.6. Likewise, sine of 40 degrees is going to be Y over 40. So Y equals 40 sine 40 degrees. Entering that into calculator, this will give us 25.7, but remember to make it negative. And now we'll put that together. So the wind vector is 30.6, comma, negative 25.7 in component form. Now we are ready to find the velocity of the plane in component form. So we'll go back to the original relationship we wrote up at the top, and that was that the resultant vector is the wind plus the plane. So that means that the plane vector is going to be the resultant vector minus the wind. And we have the resultant and wind vectors in component form. So the resultant vector was negative 102.6, comma 281.9. And the wind is 30.6, negative 25.7. The units here are miles per hour. Now we'll go ahead and we'll subtract the X and Y components. So we get negative 102.6 minus 30.6 and 281.9 minus negative 25.7. So minus negative is actually going to be addition. And if you figure this out, you get that the X component is negative 133.2 and the Y component is 307.6 miles per hour. That's the course for the plane. But we need to write this in terms of magnitude and direction, not in component form. So if we look back up at our plane vector, we got that this was negative 133.2 and 307.6. So just to see if it makes sense, this is our plane vector. So negative 133.2 horizontally and 307.6 seems reasonable. And now the last thing we need to do is convert this to polar form. So I'll just draw the plane vector in standard position. So I'm going to draw it here. And we know that the horizontal component is negative 133.2. The vertical component is positive 307.6. This is the plane vector. And now we need to find the reference angle. I'll call that theta prime, and the magnitude of the plane vector. So the magnitude of the plane vector, we're going to use Pythagorean theorem. So we'll take negative 133.2 squared plus 307.6 squared. We'll add those both up and we'll take the square root, and entering that in the calculator we get 335.2 miles per hour. And then to find the direction, I'm going to use right triangle trig. I'm going to say tangent theta prime is going to be the length of the opposite side, which is 307.6, over the adjacent side, negative 133.2. So theta prime is tangent inverse of 307.6 over negative 133.2. So theta prime is negative 66.6 degrees. Remember, we have to make sure that that angle makes sense. So in this case, negative 66.7 degrees, that would be in Q4, but our angle's in Q2, right? So how are we going to get this angle in Q2? We're going to subtract it from 180. So theta, I'll call this theta, is going to be 180 minus 66.6 degrees, and that's going to be 113.4 degrees. So finally, we know the magnitude and the course for the plane. So the vector P is going to be 335.2 miles per hour at 113.4 degrees. If you want to name it like we did normally from the positive x-axis, or if you want to name it like a direction for a plane, we could think of this as being 66.2 degrees. This was 66.2 degrees, and then it's going to be north of west. Oh, 66.6, sorry. 66.6 degrees north of west. Those are equivalent.